Number 6. Which of the following equations has both 1 and -3 as solutions? So if x equals 1 and x equals -3 are both solutions to this parabola, this is a quadratic function here, that tells me that's where they cross the x-axis. That's usually what we're trying to find. But in this case, we're going to be working backwards. So I want to find the factors that I can use to multiply and tell me which one of these answers it'll give me. So I'm going to subtract 1. So I'll have x minus 1 equals 0. Add 3, because of course this always has to equal 0. So these are my two factors, x minus 1 and x plus 3. These are the two numbers that when multiplied will give me my answer. So I'm going to do the box method for multiplying. So we have x minus 1, x plus 3. X times x is x squared. X times minus 1 is minus 1x. Positive 3 times x would be plus 3x, and positive 3 times negative 1 is minus 3. So my answer is going to be, these two will be combined here, sorry, as a side note. They're both to the power of 1, so 3 minus 1 will leave me with 2 for my middle term. So there's only one term with the power of 2, so that's x squared. 3 minus 1, like we just said, is positive 2x, and then minus 3. So this is our answer. This is the quadratic equation that gives us solutions of 1 and -3. So that's going to be answer B. And just, here, let me just show y'all something really quick, just in case this isn't making sense. If I was to graph, put this here, let me see it, x squared plus 2x minus 3, and then if I also graph what I know my solutions are in the factors, I'm going to do x minus 1 and x plus 3. I'm going to graph both of those, and now let's see what happens here. So there's the first one, and here comes the second one in red. So we can see they're the same, so we know our answer is correct, just as a double check. And there's my y equals, just for reference, if y'all want to check as well. All right, so these solutions, we worked backwards, multiplied, and we got our answer. All right, number 7. Keep moving here. In the xy plane, what is the y-intercept of the graph of the equation? Oh, I'm sorry, my dog. I need to pick him. Hold on. Come here. Hurry up. Come on. This is Max. He says hi. Hi, everybody. Okay, so in the xy plane, the y-intercept of the graph of the equation. Okay, so the y-intercept, quick sketch here. So if we have a graph and we want the y-intercept, that's where it's crossing the y-axis, right? What is the value of x when it's crossing the y-axis? Here's 1, here's -1. So the value of the y-axis is 0. So that tells us that if we want to find the y-intercept, that's going to occur where x is 0. So we're going to plug that into our function here. So y equals 2 times 0 plus 3 times 0 minus 4. So we just took this value, the value at the y-intercept, x equals 0. So we put that in. Y equals 2 times 3 times -4. 2 times 3 is 6. 6 times -4 is -24. So our y-intercept for this function here is at a -24. All right, number 8. X to the 4th minus 1. Okay, so we're going to simplify this. So this is called a difference of two squares. Or excuse me, difference of squares, either way. This is x squared times x squared. This is 1 times 1, and there's a difference. So what we can do is say x squared plus 1, x squared minus 1. This is the rule. This is what you do when you have a difference minus of two squares, x squared, and this is 1 squared. So we take x squared times x squared, 1 times 1, and it'll give us this back. So, are we done? No, we have to continue. So, keep factoring it as much as you can. Now, this x squared plus 1, it cannot be factored any further, so it's just going to hang out. But here, we have another difference of squares. X times x will give us x squared, and 1 times 1 will give us 1. And of course, as the rule goes, it's always plus 1 of them and minus 1 of them. Just like here, plus, minus, and again here for this one, plus, minus. So this is going to be our final answer, as simplified as it can be. So we have x plus 1, x minus 1, x squared plus 1. Our answer is A. Okay, continuing on with number 9. 3x squared y cubed all to the third power. So anytime something is raised to a power, the power has to get on everything. So I'm going to rewrite this, 3x squared y cubed to the third power. That is the same as 3 cubed x 2 times 3, y 3 times 3. When you have an exponent on a power already, so if a power is raised to a power or an exponent is raised to an exponent, you multiply the numbers. So this is x to the 2 times 3. This is y to the 3 times 3. So this equals 3 to the third power. 3 times 3 is 9. 9 times 3 is 27. X to the 6th, y to the 9th. 2 times 3 is 6. 3 times 3 is 9. So 27, x to the 6th, y to the 9th. Our answer is D for number 9. Number 10. If the square root of 5x minus, if the square root of 5 minus x equals 4, then x equals, so we're just solving for x. So square root 5 minus x equals 4. We need to get rid of that square root sign. So how do we do that? We square it. And whatever you do on one side of the equation, you have to do on the other side. So by squaring a square root, the square root goes away. So it's just 5 minus x equals 16. 4 times 4 is 16. Off to the side here really fast. If I have the square root of x and I square it, that just gives me x back. If I have the square root of y plus 1 and I square it, it's just going to give me y plus 1. So the square of a square root just makes the root sign go away. We're just left with what's underneath, like in both of these cases. Okay, so back to number 10. We have 5 minus x equals 16, so I'm going to subtract 5 from both sides. That is eliminated. Negative x equals 11. And of course, you can never have a negative variable for your end answer. You have to have x equals something. So I'm going to divide by negative 1. That will cancel. Negative times or negative divided by a negative is positive. And whatever you do on one side, you have to do on the other. So x equals negative 11. 11 divided by negative 1 is negative 11. So the answer here is B. Keep up the good work.